So you kind of already know what the weightage is. And I mean, the A is 0, 1, we can ignore that. Where's the... Yeah, I guess these are your two papers. You've got your paper 4 and paper 5. So we can discuss these just a little bit.
Mm.
So paper 4 is it's like your typical structured paper, like your paper 2. But it's like a very big paper. That's
Mm.
so
And
this one is for 100 marks. So it's kind of really lengthy. And
uh,
and in AS you had your 1 hour 15-minute papers. You've got your 2 hour paper. This one is a 2 hour paper. So it's a lengthy paper, and but so normally you're going to have 7 to 9 questions. And normally in every paper, there'll be kind of two questions that are going to be very difficult. One or two
uh,
questions. The others would be if you study well, they'll be straightforward and you'll answer those like if you've studied well. But there are going to be one or two questions. Normally there's just one where students get stuck. And that one question is normally always there. And so it's kind of like your paper too. It's got a very big weightage. That's 40% overall in A levels. So that's kind of like your 50%, almost, I mean, almost half of your grade depends on this paper. Is that clear?
mm, yeah.
Like your paper
Mm,
1 was like something like 13, 14%, right? 15%, I think.
okay.
Your paper 3 was like 11%. Your
Uh,
paper 2 was like 23%. This is like close to 40%. So that determines a lot of your grade. And then you have this tiny paper 5, which is kind of very easy.
this is like practical paper.
Yeah, but it's like an ATP paper, alternate to practical.
Okay.
And it's not even an alternate to practical paper. It's more like a common sense paper.
Okay.
Like like you'll be asked really simple basic things. And
Uh,
you just have to use a lot of common sense. So it's not that difficult. Like your practical has tests you a lot. When you're doing your practical,
mm,
lot of your knowledge gets tested. In ATP, you don't, nothing gets tested, by the way. I mean, even if you haven't prepared for ATP, you just use your common sense properly, you'll
mm,
still be able to do your ATP paper. So normally what happens is, just one second, let me mute this. I said, normally what happens is that people just keep this or do this at the end. Uh,
mm,
we'll probably do a few papers. I mean, and normally what happens is you don't even have to like prepare anything for this. Your general knowledge of your practicals and your
mm.
general overall knowledge of your chemistry, that's sufficient.
Okay.
I mean, if you know what a beaker does, if you know what a
Mm,
conical flask does, and if you're prepared for this, that knowledge is sufficient. All you
okay.
need is a lot of common sense, and you just have to practice papers for preparing this.
Mm,
You just practice papers, and let me show you this part because one second. If I open one ATP paper, just one second. I say if I open one, not I mean it's known as a. They keep changing the name. I think it's design analysis or design and planning. Anam, can you hear me?
Assalamu alaikum, sir. Yes.
ठीक है. So बस वो Anam, just a brief वो मुझे बता दो कि what's your background? You just did your AS in May June.
Yes, sir. We were actually writing AS last year in October, November, and A levels this year, October, November.
आप कहाँ से हो? Which city are you from?
Um, I'm from Mozambique, Southern Africa.
अच्छा ठीक है. See, why are you doing in October, November? Is that the normal trend over there?
Yeah, it's the normal trend over here. Our batch starts in Jan till October, November.
अच्छा ठीक है. So that's ठीक है. So but you haven't studied. You've studied your A levels or not?
Yeah, I think we're halfway through with the syllabus, just half more left.
अच्छा ठीक है. So ठीक है. For you, I think it's more like an exam class. So uh, तो फिर we'll be doing a lot more past paper practice with you. ठीक है.
All right.
अच्छा. So ये बस वैसे ही. I'm just trying to give you an overview. Okay, this is your ATP paper. ठीक है. Jack Fisher, I just wanted to show you that. In ATP paper, what they do is just getting the name right. Planning, analysis, and evaluation. That's the paper name. ठीक है. So what happens is you got two questions in this paper normally. And normally what happens in paper 5 is that you've got a planning paper. There's simple calculations that they're going to ask you. Calculate the concentration of dissolved oxygen in the 25 cm cube solution. It's probably going to be an easy question. TK. We're not going to do that. Suggest a suitable piece of apparatus for the transfer of 25 cm cube. That's a pipette. So it's like very basic. Water samples are collected in full sealed flask. Explain why the sealed flask must be completely full. So you just have to make up some common sense, like why I mean, they're trying to, I think, test some water samples. So you're going to read through this and you're going to try and figure out that what's going to happen if the flasks are not completely full. So my hunch is that if the flasks are not completely full, I'm just making a hunch. I didn't even read the question.
Yeah, okay.
So if the flask, it's toppered over here and you don't fill it up till the top, so maybe there is air that's going to get trapped into it, and if they're trying to test the water sample, so that sample might react with the air or something like that. Okay, so for that you would have to kind of read through this. Yeah,
Okay.
I mean, they did say that the concentration of dissolved oxygen in a sample of water can be measured using the following method. Is oxidized by the oxygen dissolved. So they're trying to figure out the oxygen that's dissolved in the water, right? So obviously that makes sense. Like you take the water, so there should not be any air in it, right? Because that air will have oxygen in it, and the concentration of the dissolved oxygen might change because of that. Some of the oxygen might. So you get the point, right?
Yeah, I
So
get it.
I'm just trying to make the point that it's a lot of common sense that so they've given you a data, they're asking you to make a graph. They're trying to find the anomalous point, which is, I mean, if you've ever made a graph, you know what an anomalous point is.
Mm.
And then there's a design or planning part as well, which is question number 2. For example, over here, planning is you're being asked to draw a label diagram to carry out an experiment. Whatever the experiment, if you have some knowledge of what's going on, you can read through it. You can sort of sketch an apparatus, right? So that requires practice. You have to practice a lot of papers. They've
Yeah.
given you data for that. They might, for example, they're asking you to find the initial rate of the reaction. So they might ask you stuff related to that. So, and that's it. Okay. So there's going to be some evaluation. They might give you some data and they might ask you a bunch of questions. The thing with this paper is every time it's going to be a completely different experiment. And when it's a completely different experiment, every time you just have to think a lot. Okay? You just have to use a lot of common sense. So when we practice this, it's not going to be that difficult. So initially, I'm not really that interested in paper 5. We'll do one paper 5 once, like in 2 weeks, one paper 5, we'll go through that. But once we do 2-3 papers, you'll get an idea of what paper 5 is. Mainly, we're going to do we're going to prepare for paper 4,
Okay.
the 40% weightage. Now, the thing is that, where's the syllabus? I'll just quickly go through the syllabus. What are the topics? Yeah, this one. And we can start. Anam, आपने last कौन सा topic किया था?
The last topic we did right now was no, not electrolysis. I'm sorry. We were going to start with benzene ring.
You're up till you're starting at this point, right? Organic, right?
Yeah, we're about to start organic.
As in you did the previous ones, right?
Yeah.
Did you understand all of that?
I usually face difficulties in electrolysis and transitions.
I mean, those are big topics. Even equilibrium is difficult. A lot of people find equilibrium very difficult. This one
Yeah,
is easy.
especially the ASP.
Uh-huh. I mean, equilibrium, you've got a lot of things. You've got Ka, you've got uh, KW, you've got KSP, you've got KPC as well. Anyway, so 4 topics in physical chemistry, that's energetics, electrochemistry, equilibrium, and reaction kinetics. This is kind of like a continuation of your AS. In AS, you did not really study electrochemistry a lot. And you did not really study reaction. I mean, you studied like 10%. You studied like 5%, the introduction part in AS. But you really did not even touch the topic in AS. So these two topics are mostly going to be in your A levels. The other ones you kind of did a lot. So we're going to first revise the previous stuff as well. Because remember, in your A levels, what happens is that uh, they can ask you stuff from AS as well. Especially when you're doing energetics, half of the things you studied are your basics in AS. Same with equilibrium. Half of the things you studied are your basics in AS. So without those basics, you can't really move on. So you'll be tested on the whole thing. In organic chemistry, group 2, you studied a lot of it in AS. You're going to do a few minor topics in A2 related to group 2. Transition metals is the one that's what you're going to study. And there's going to be a lot of benzene related stuff that you'll be studying. अच्छा ये किस तरह दिया हुआ है? एक second. Is this? अच्छा ठीक है. So there's going to be a lot of benzene related stuff. So again, the problem with organic is that by default your AS organic is going to be part of your syllabus. Why? Because your reaction charts, your reaction schemes are going to be incomplete if you don't include AS. So that kind of makes it difficult. So this involves AS. Inorganic, not that much. Okay, you don't really have to study, but there's going to be a lot of AS stuff that will be coming into this. And finally, you'll have your analytical techniques. You did do some of the analytical techniques in AS, but you're going to cover a few more. Most likely, I mean, the only one I think that's left is NMR. You already did infrared. You already did mass spectroscopy. So infrared and electrophoresis. Sorry, NMR and electrophoresis. A couple of more that are left, which you're going to cover in this. So we're going to start. So we're going to start now, and we're going to start with energetics. Okay, and remember, we're going to start all the way from the back. Okay, we're going to revise AS quickly, and then we're going to start do our A levels energetics. अब इसमें starting with, you already know what endothermic and exothermic is. So endothermic is positive gain of energy. Exothermic, that's negative. That's heat energy being produced. So the first thing is, since you've got endothermic, exothermic reactions, you need to know some examples of endothermic reactions. For example, there is endothermic में क्या क्या आता है? That's a decomposition reactions. A lot of your decomposition reactions are endothermic. You've got photosynthesis. Changes of state from endothermic would be solid, liquid to gas. So then you have what else? You've got okay, any other idea of an endothermic reaction? Electrolysis is endothermic. Dissolving salts, some salts. Exothermic so exothermic reactions are combustion. Changes of state, gas or liquid to solid. You've got respiration, which is the opposite of photosynthesis. You've got a lot of nuclear reactions that are exothermic. So then you have electrochemical cells, which are exothermic. They produce electrical energy. And what else? What's it here? So those are some exothermic, endothermic reactions. You've got energy profile diagrams, जो कि मैं simple directly. I can just copy energy profile diagrams. You remember all of the basis stuff can be part of the paper. Labeled copies again. So let's do this one. Okay, I'll quickly try and go through all of this. I said this one. That's an कौन सा ये exo endo? What is that?
Exothermic.
Okay, that's exothermic. When you're breaking bonds, energy is gained. Every reaction, the first part is you're breaking bonds, and that part is endo. And then when you're forming bonds, energy is released. So that part is exo. Okay, so every reaction has this endo part. It's got this exo part, and overall, if more energy is released, that makes it exothermic. Activation energy is the energy that is needed at the start of the reaction. Or specifically, it's the minimum energy that is needed to start a reaction. Particles have to collide with enough force so that they're able to break bonds. Once those bonds are broken, new bonds are going to be formed. What a catalyst does is it lowers the activation energy, which kind of speeds up the reaction because now the reaction would be easier. In every reaction, breaking bonds is the difficult part. If it becomes very hard to break bonds, the reaction is going to be very slow. Okay, so catalyst reduces activation energy. So ये सारा तो ठीक है. So based on this, the first formula or एक बीच में I can add an endothermic one. Got it.
Sir,
Yes.
by when will we be done with the syllabus?
We'll be done in 4.5 months. November. I think sorry, आपका तो October है ना? For you, we'll
Yeah.
what we can do is we can have extra classes
Okay, sir. All right.
to cover the For example, if you want to go over organic, we can have separate classes for that. Okay. So for you, it's going to be more past papers. Okay.
Okay, sir.
I shall this one. Ito, okay, we got to do the first formula, which is formula number 1, and we're going to practice some questions. The first formula is that the overall energy of a reaction, enthalpy change of a reaction is, it's the energy that is required for bond breaking minus the energy that would be released when you're forming bonds. You're breaking bonds in the reactants and you'll be forming bonds in the products. When you form a product, you'll be forming bonds. So that's our first formula. And for this, you need bond energy. You need bond energies, which are given in the data booklet, but now they're going to be printed next to the question. So bond energy is the energy that is needed to break 1 mole of bonds. And if you're forming the bond, it's going to be the same energy, but it's going to be released. Of the same type. But the problem with bond energies is that they are only defined for gaseous molecules. So if a substance is a solid or a liquid or any other state, you can't use bond energies. In that particular case, you have to use other formulas. Bond energies make you're going to have exact values. If they're all the same type of bonds. Example is that a Cl-Cl bond energy would always exactly be the same. Why? Because if there's another Cl2 molecule, it's going to have exactly the same type of bonds. But then for some bonds, you're going to have average values because they can't be calculated exactly. In that case, the bonds, all of them are not exactly the same type. For example, if I have a ethanol molecule and I'm looking at the CH bond energy, then these CH bonds are not all of them kind of exactly the same. But this CH bond and this CH bonds, they're not exactly the same because they're not bonded in exactly the same way. So, so all the CH bonds in this molecule are not here. Some molecules will be using exact values for bond energies, but in other molecules, you'll be using average values. TK, is this clear?
Yeah, yes, sir.
Yes, sir.
Achha, then the thing is with bond energies, you'll be asked to sometimes write equations. So, for example, show a reaction which represents AlCl bond energy. Now we know that if it's an AlCl3 covalent molecule, right? So AlCl bond energy is that you're going to break 1 mole of Al and Cl bonds. So you take an AlCl3 molecule and you're going to break the Al and Cl bonds, but only one of them. So you'll be left with AlCl2 and one of the Cl would be broken, right? So basically, you've broken 1 mole of AlCl bonds. So the enthalpy change of this reaction would be equal to the bond energy of AlCl. So remember, bond energy is when you just break 1 mole of a particular type of bond. So in this case, you've broken exactly 1 AlCl bond. Or the other thing that you could have done is you could have broken 3 moles of Al and Cl bonds. And if you had done that, you could have done that. So there's going to be 1 Al left and there'll be 3 Cl. But this time it would be, you'll be breaking 3 moles of AlCl bonds. So bond energy is for 1 mole of AlCl bond. So what you're going to do is you're going to divide the whole thing by 3. And the molecules have to be, everything has to be, the state symbols are important. They all have to be gaseous. Okay, so both of these representations of AlCl bond energy are correct. In the first one, you broke 1 mole of AlCl bonds. So you got AlCl2 and the Cl is broken away. So the enthalpy of this reaction is basically equal to bond energy of AlCl. In the second one, you broke 3 moles of AlCl bonds. But since you divided the whole equation by 3, so now in effect, you're breaking just 1 mole of AlCl bonds. You don't know clear? Is this clear?
Yes, sir.
Jaksha, is this clear?
I'm a little confused about the 1/3. How did it become 1 mole?
No, forget 1/3.
Oh, okay.
How many bonds have I broken in this? Like if I don't write 1/3.
Mm,
Like I've
is
got,
it 4?
I mean, this is AlCl3, right?
Mm. Or is it 3? Was 3?
So I've broken 3 bonds, right? 3 moles of bonds, right?
Yeah.
So the enthalpy of this reaction is basically equal to the bond energy of AlCl3 multiplied by 3, right?
Yeah.
Because I'm breaking 3 AlCl bonds, right?
Mm.
So basically the question was that you had to represent just the AlCl bond energy, not 3 times the AlCl bond energy, right?
Yeah.
So you just divide the whole equation by 3.
Okay.
So once you do that, so you're just taking 1/3 of the moles. So automatically now, whatever your enthalpy change is, it's going to be equal to AlCl bond energy. Is this clear?
Yeah.
So anyway, so bond energy is not that difficult. Now the thing with bond energy is you're just breaking 1 mole of bonds, right? So there can be exact values where every bond is of exactly the same type, or there could be average values where sometimes what happens is that they're not exactly the same. They're the same type, but they're not exactly 100% the same. This CH would be different than this CH compared to this CH. And plus, the other thing is you have to remember that smaller atoms always make stronger bonds. So they're going to have higher bond energy. And also remember that your double bonds are stronger compared to your single bonds, and your triple bonds are stronger than your So triple bonds are stronger than your double bonds. So that's it, bond energy, right? And then you have this formula. So we're gonna do a bunch of questions related to just bond energy. And also make sure you remember this, that bond energy values can only be used for gaseous molecules. So only for gaseous molecules. So I'm just going to do a few questions. 1 second. Okay, remember, for every topic, we're going to start with AS, then we're going to continue with A2. So where's bond energy? This one. So let's do this one quickly. So basically in this reaction, we're just going to do this one question. You just have to figure out how many bonds are broken. So bonds broken will be on the reactant side. So you're breaking two CH bonds. That's 1 and 2. You're breaking one triple bond between carbon atoms. That's the middle part. And you're breaking O double bond O. And you're breaking how many? 2.5 of them. And that's all endothermic. That's all plus. So it's going to be 410 times 2. Plus C triple bond C is 840. Plus O double bond O is 496. So that's your bonds broken, and bonds formed will be on the. So when you have water, you've got two OH bonds that you're forming and CO2 molecules. So what happens in CO2 is that you got two CO2 molecules. So that's C double bond O, 4 of them. So bonds formed is exothermic. So that's 2 OH, that's 460 times 2, that's minus. And minus 4 times C double bond O, that's minus 4 times 740. You're going to add all of this, and that's going to be your enthalpy change. Bonds broken minus bonds formed. Does anyone have a calculator and can do the calculation? Kara, what do we get for this? Anam, Jakusha, any idea?
Oh, wait, for exothermic is minus 460 times 2 minus 4. Is that 4
4,
times?
740, yeah. C double bond is 740.
4. I get minus 1724.
For this part only?
No, like together.
I think there must be something.
Okay.
One important thing is you have to be very careful with your math. It's good. Try and go do this again. 1 second. Anam, do you try this? Okay, 840 plus 496. I just saw you 496 times 2.5. I missed that. Now do this. So that's 2900. And then it's minus 460 times 2. And plus 4 times 740. So that gives me 980. So you have to be very careful with your math, addition and subtraction when you're doing questions like these. Okay, so that's question number 1. Okay, that is AS, and that could be A2 as well. Okay, is this clear? The first formula, is that clear?
Yeah.
So okay, we continue with this tomorrow then, right? We'll just go through AS very quickly and then we'll start A2. Okay?
Yeah.
Chale. Okay then. Take care, everyone.